So far, when we've encountered roots, they've simply been square roots, and they have been fairly simple to figure out. So like something like square root of 100. And we found that we do have a plus or minus, but in this case, we're just going to be taking the principal root. So unless it's indicated otherwise, we want the positive answer. So we'd simply say that the square root of 100 is 10, and we wouldn't need the negative part here. But now we haven't really dealt with, well, what if I had a cube root? So let's take a look at why the square root of 100 is 10. So what we've really done is we've taken this 100 and we've prime factorized it down, like so. And I see that I have 2 squared times 5 squared. And so if I were to show all the work involved with this, I would replace 100 with 2 squared times 5 squared. And then I say, well, I'm doing a square root, which means I'm asking what number times itself will give me 100. So in the case here, this number right here is called the index. And then inside of all here are the powers. What I do is I take my powers and I divide them by my index. So 2 divide 2 is 1, so I have 2 to the first, times, here's my 2. 2 divide 2 is 5, so 5 to the first, and I get 10. So in this case, though, easier to just 10 times 10 is 100. Now, let's take a look at the cube root. This is going to ask, well, what number times itself 3 times will give me the 27? And one way to do this is that prime factorizing. I could do 27, and 3 times 3 is 9, or 3 times 9 is 27, and then 3 times 3. And I get cube root 3 cubed. What I do is I take my power, my 3, and divide it by 3, and I get 3 to the 1. And notice my radical is gone. So like over here, I don't say that the square root of 100 is square root 10. I've done the square root. So over here, if my index is not written, then it is a 2. So this is a square root. And all I have to do, 8 divided 2, is x to the 4th. Okay, now we're going to get into a technicality before I get down here. If I do, and I'm not really too concerned about this one, but let's just go ahead. If I'm doing a square root of an even power, and I get this, x, technically I need to say it's absolute value of x because I'm doing the principal root. Because I could have negative x is one of my answers. So I don't need to worry about that if, however, this happens. So the square root of x to the 4th is x squared. Well, that squared already takes care of the negative because a negative times negative is a positive, so I don't need to do absolute values there. All right, let's take a look at this one. Now, 9, we're going to say, well, wait a minute. 9 is not divisible by 2. So what I'm going to do is I'm going to walk my power backwards until I get a number divisible by 2. And the first number, if I go back 1, is 8. And we see 8 plus 1 is 9, so I haven't done anything, and my y squared is fine. So 8 divided 2 is x to the 4th. I can't do the x to the 1, so that stays on the inside. And the square root of y squared is y, so leaving me with square root x. Now, this y needs to be in absolute values because I did a square root of an even power and got an odd power, so that needs to be in absolute values. Okay, this next one. Now I need a 3. So I need these divisible by 3. So again, I'm going to walk this back. So if I go 14, 13, 12, 12 is divisible by 3. So the first one that I come to that's divisible by 3 is the one that I want. So I have x to the 12th times now x to the squared. If I add those up, I get my 14. Same with the 10, but that's y to the 9th. Now, the cube root of x to the 12th is x to the 4th. Now, I don't need to worry about negatives or absolute values or anything for an odd power. So I don't need absolute values at all for this one. So I could do this. So it's out there. So that means cube root inside, I'm left with an x squared. And then I can do this one. So cube root of that. See, I'm just doing my power divide, not a 3. So I get 3, because 9 divided 3 is 3. And I can't do this y, so that's on the inside. Okay, so now I'm doing a fourth root. So I need these divisible by 4. So if I think of 15, 14, 13, okay, 12 will work. So I have fourth root, x to the 12, x to the 3. So those powers need to add up to the 15, and y to the 20 is fine the way it is. All right, so the fourth root of x to the 12th is x to the third. Okay, now that's going to need to be in absolute value because I did an even thing. Doesn't matter if I put the absolute value on the outside of the cube or whatever. I want absolute value there. So the fourth root of x to the third is still on the inside, and then I have y to the fifth, and again, that is an absolute value. Okay, so there we go. Let's try a few more. So here we have a square root, and we have square root of 16, so that's 4. And then the square root of x to the fourth is x squared, and I don't need to worry about absolute values because it's only if I have an even root but get an odd power that I need absolute values. So I need absolute value if I did an even root but got an odd power, because the odd powers could give me a negative, and I want only the principal roots. Now here I have a minus, which means I need the minus root. I want the negative root. So this is all a group here. I don't want to multiply it around or anything. The square root of a fourth power is a squared. So I have x to the third plus 5 squared right there. And a negative, because I wanted the negative root. That one's done. So I don't need to worry about absolute values there. I want the negative root. Okay, so now I have, we'll come back to this one. That was a little bit lengthy. Now I have a square root of a negative. So the first thing I'm going to do is remember my imaginary stuff. I do have a square root here, so I split this up. But this is imaginary, so I'm going to have an I out here. So the square root of 25 is 5. Square root of x squared is x. Square root of y to the fourth, or y to the eighth is y to the fourth. And then left on the inside, so I did these, and I did this, that leaves me with xy, and then I have an I. I like putting the I last, just make sure it's not left in that radical. Now, I do need an absolute value here, because I did a square root of an even power, and got an odd power, so that one needs an absolute value around it. Okay, this one. So I want a cube root, so I need to split these up so they're divisible by 3. So x to the 9. So you take the highest power. Y to the third is fine. And then z. I want a z right here. To the 12th, it looks like. So those add up to 14, and those add up to 10, so we're good. Cube root of x to the 9, x to the third. Cube root of that. Cube root of that. And now I need to think, well, what is left on the inside? Well, I did this. I did this. I did this. So that leaves x z squared. And I need to remember this as a cube root. When we do odd roots, we don't need to worry about our absolute value. So I have a negative right here. So the first thing, I have an I. Now that 32 I'm going to need to deal with because I am doing a square root. So I'm going to prime factorize my 32 and make it look like it was a variable. Don't want to drop that 2. And I see I have 1, 2, 3, 4, 5 2's. So this is 2 to the 5th. I'll split this y up. And I don't want to lose my I. So I split up that 2. Okay, and I do have my I, don't drop that. All right, so the square root of 2 to the 4th is 2 squared. Square root of x to the 4th is x squared. Square root of y cubed, or y to the 6th is y cubed. That needs to be an absolute value. Then what am I left with? I am left with, I did this, I did this, and I did this. I'm left with 2 y I. Now that 2 squared I can do, so I go ahead and do it. And there's our answer. So we're going to come back up to this 243. And I'm going to need to go ahead and prime factorize this. So 243, and I might not be like, well, what is that going to be right there? Well, 243 is divisible by 3. So let's see, 243 divisible by 3. We can just test on a calculator. So we have 8, 24, 0, 3, so 81. So I have 3 and 81, 3, 27, 3 and 9, 3 and 3. All right, so I have 5th root, and I have 1, 2, 3, 4, 5 threes. That's convenient. X to the 10, y to the 15, z to the 12. I need to split up to 10 and 2, because 10 is the first one divisible by 5. So the 5th root of 3 to the 5th, 3. 5th root here, x squared. 5th root here, y cubed. 5th root here, z squared. And then 5th root, z squared. That's a 5. This is our answer. No problems. Okay, we're winding down right here. It's a lot of stuff. All of these are square roots that we're going to end with. Let's see, do I have others? Maybe, yeah. Okay, so in order to do the square root, I'm going to prime factorize my 120. See if anything pops out. All right, there we go. So I have, rewrite this, square root. I have 3 2's. So I'm going to split that up right away. See, 3 2's, 1, 2, 3. If I add those up, why did I split it up? Because I'm doing a square root. I have x squared. And y to the 6th is fine. Divide these by 2. So I have 2 x and y to the 3rd. And left on the inside is a 2. Now I need an absolute value around these. Which ones? This one and this one. Okay, right here. I have a negative. So square root. Throw my I. I'm not going to bother prime factorizing the 49 because that's a perfect square. Square root of 49 is 7. Square root of x to the 4th, x squared. Square root of y squared is y. I have my I out here. And then I have an x left over. This one in absolute value. Why? Because I'm doing an even root. And I got an odd power. So that needs to be in absolute value symbols because we are doing the principal root. Over here, 90. So I'm going to prime factorize that. And then 45 times 2. Maybe 5 and 9. And 3. So once I get all prime numbers, I'm done. So this is square root of 3 squared times 2 times 5. I split this x cubed up, and the y to the 6th is fine. All right, so this is a square root, so 2 divide 2, 1, so I have a 3. So I did that. I'm not going to be able to do those, so 10. I can do this, so the square root of x squared is x. Absolute value, though. And I can do that. That's y cubed. Again, absolute value. And then, see, I did that 2 times 5. What else am I left with? An x. And there we go. I'll just show that. Oh, got it. Okay. There we go. Last ones. All right. So cube root. 64 is a perfect cube. It's 4, but you could prime factorize that if you wanted. And then if I cube root that, okay, that's good. I did 6 divide 2, and that's good enough. I can leave that. All right, 625. Well, it just so happens 25 times 25 is 625. So if I were to prime factorize this, I would get 5 to the 4th. And this is fine the way it is. Okay, so the 4th root of 5 to the 4th is 5. And then the 4th root of that, 3x minus 7. So you divide that by 4 and get 2. And I'm good. Okay, so just the besides all of this, like an important thing to remember, the absolute value. So if I did, say, square root of, let's say, x squared, I get x, but an absolute value, because I got an odd power from an even root, from an even index. Okay, that takes care of exponents and radicals.